Hello there. Welcome to another Unity tutorial. In this tutorial, we're going to learn about two of the principles of object-oriented programming, inheritance and polymorphism. We'll create two scripts to learn about these principles. The first one will be to create a very simple moving platform that moves between some predefined points. The second script will be a variation of the moving platform, which we use to turn the moving platform into a death wall that will end the game when it makes contact with the player and cause any of the mine agents that it makes contact with to detonate. So first we need to create an object in our scene to represent the moving platform. So I'm going to right click in the hierarchy, go to 3D object and create a new cube. We'll reset the transform of the cube and we'll just move it somewhere else in the scene. Okay. So the cube, I'm going to set the transform, the scale on the Y is going to be 0.5, and then we'll make it like 3 on the X and the Z axis. So that's going to be our moving platform. Now we don't need to worry about the mesh filter or the mesh renderer, so I'm going to minimize these. Now we do want to add another box collider. So I'm going to click add component and look up box collider. Now this top one, I'm going to set is trigger to true. And right now, the two colliders are overlaying each other. They're like right on top of each other. Now the trigger, I want to sit on top of the platform. So I'm going to set the Y position for the trigger collider's center to 1. And you can see that it sits nicely on top of our platform now. Okay, so let's rename this object to moving platform. And next we'll create and add a script to this object. So I'll click add component, type in moving platform, select new script, make sure the name is correct, moving platform, no spaces, capital M, capital P, and then select create and add. Okay, you can see that the script has been added to our object. So let's open it from the project window. Okay, so here's our script, and we'll start as usual by declaring the variables we need. So the first variable we're going to need is going to be a serialized protected variable, and it's going to be of the type float, and we'll call it speed and give it a default value of 3. Okay, so next we're going to actually need to have two arrays. One to track the points that our platform will move between, and the other to track the amount of time that it should wait at each point. So we could create two arrays, separate arrays, and track them in that way. But this is a case where it makes sense to create a new class to store this information. Then we can simply make an array of the class type and feed the data that we need to store into each instance of the class in the array. So above my variables here, I'm going to create a public class, and we'll call this platform target point. So this is an example of a nested class. It's a class, right, that has been defined within another class. So if we wanted to get access to this class outside of the moving platform class, well, we would actually access it through the moving platform type. Now in this case, we just want to use it to store some information relevant to this class. So it's going to have two variables within this class, and they're both going to be serialized. So we'll open serialized field within this class, and we're going to have a private transform, and we'll call that point. And what that's going to represent is it's going to hold a reference to the position for this particular point. And underneath that, we'll have another serialized variable, which will be a private float, and we'll call it idle time. And that's going to be the amount of time that the platform waits for at this point before moving on to the next one. So we could give these tooltip attributes because these will be visible in the Unity inspector. Oops, tooltip. So this will be the point that the platform will move to. And the second one will be the amount of time the platform will wait for when it reaches this point. Actually, while we're doing tooltips, let's just quickly add one to our speed variable as well. We'll say the speed the platform moves at. And we're not quite done defining the platform target point class yet, but we will define our array now. So underneath our speed variable inside the moving platform class, we're going to create a new serialized protected variable, which will be of the type platform target point, which we just created. And this is going to be an array, so we need to follow that with a set of squared brackets. And the name of this variable we'll just call points. You might think we should be able to see this in the Unity inspector because it's serialized and it's a public class. The thing is, because this class does not inherit from mono behavior, Unity doesn't inherently know how to interpret it. So we actually need to add an attribute to the class itself. So above the class type, I'm going to open a set of squared brackets. And here we're going to say system.serializable, which defines this class as information that can be interpreted by Unity. So once we have that, this array here, this points array, will actually be visible in the Unity inspector, and we can assign references and values to it through the inspector. Now we'll give our points variable a tooltip, and we'll just say the list of target points for this platform. Okay, so that's all our serialized variables. Underneath that, we'll have a protected integer, which we call current point index, and we're going to set that to 0. Underneath that, we'll have a protected float, which we call timer, and we're going to set that to -1. So you might be wondering why we're using protected for these variables within the moving platform script. Well, that's because we want any scripts that inherit from the moving platform script to have access to those variables if they need to. Okay, actually, we need to finish our platform target point class. Now, these variables are private, so we'll be able to set them via the Unity inspector, but because they're in a separate class, right, we have no way of actually accessing this information from outside of instances of the platform target point class. So we'll use some properties to return the value of each of these variables to outside of the class, which we'll do by saying public transform will be our first one, and it will be point with a capital P. Open the set encoding brackets, say get, and then inside the coding brackets for our getter, we'll say return point. So we can use this property here to read our point value. Now the next thing we're going to do is going to be the same thing. It's going to be a public, this time float, and we'll call it idle time. And same thing, set of coding brackets, the get keyword, another set of coding brackets, and then return idle time. So now we have a way of reading our idle time from outside of the platform target point class. Okay, so let's scroll down and begin defining our methods. So first we'll turn these default comments into method summaries. Cool. Okay, so in the start method, all I'm going to do here is write a comment, and we'll say reset platform to starting position. Okay. Now we're going to write a method for that, and we'll replace this comment once we've done that. But there is actually one other thing I want to do with the start method, and this is where we need to consider inheritance. So any scripts that inherit from our moving platform, they might want to do extra stuff in the start method or completely different things. So we need to mark this method as something that can be overridden and extended. So in our method definition here, we are going to mark this first as protected so that any inheriting classes actually have access to it. And to mark it as something that can be overridden or extended, after the protection level, we then need to use the virtual keyword. So that's marked the start method as a method that can be overridden or extended from any classes that derive from the moving platform class. And we'll do the same for our update method as well, because that's going to need to be the same. But before we start writing our update method, let's quickly inherit the fixed update method from MonoBehavior. And this one doesn't need to be protected because all moving platforms will work the same way in the fixed update. In the fixed update, all we're going to do is have the platform move towards its current point. So our summary for this will be a fixed update, maybe called more than once per frame, just as a little reminder for ourselves. So inside the fixed update, what we're going to do is we're going to check to see if our timer is less than 0. So if it's not counting, because if it's equal to or greater than 0, then it will be counting. So if the timer is not counting, we want to change our platform's position. So we'll say transform position, and we're going to add a position onto the current position. So we'll say plus equals, and we'll say speed multiplied by time dot delta time multiplied by, and here is where we need to get the direction to our current point. So I'm going to open a set of brackets here, and here first I'm going to say points, and open a set of square brackets and say current point index to pass the index of the current point that we're moving towards to the array. And then from that point, I want to access the point at that index, and then I want to get the position of that point. Then I want to subtract the platform's position by saying minus transform position, which will give me the direction from the platform to the point that it's currently moving towards. Next, we'll normalize that value by outside of the brackets there, we'll say dot normalized, and then close the line so that we get a nice even movement every frame. Okay, so next let's do our update method. So the update method for this object is going to be comprised of two sort of sections defined using a set of if statements. So we'll say if timer is greater than or equal to 0. So if our timer is counting, in other words. Now, if that's not the case, we actually want to check for something very specific. So I'm going to use an else if statement here. And we want to check the distance to the current point and see how close we are. And if we're close enough, we will start our timer. So here we'll say if vector3.distance. So this is a method that you can use to check the distance between 2 points. And we're going to check if the value of that is less than 0.1f. So if we're within a tenth of a unit of our target position. Now, to find the distance between the platform and the position, the point that we're moving towards, we'll say inside the parameters for vector3.distance, the first parameter will be transform.position, and that's going to pass the position of the platform. After that, we want to pass the position of the point that we're moving towards. So just like in the fixed update, we'll say points, then open a set of squared brackets, and inside that say current point index. Then after that, we'll say dot point to access the point that is associated with this point. And then we'll say dot position to access the position of that point. So if this statement here executes, it's actually fairly simple what we need to do. We're just going to check if timer is less than 0. So if our timer is off, and if it is, we'll set timer equal to 0, which will start it counting. Now, if our timer value is greater than or equal to 0, the first thing we need to do is increment our timer. So we'll say timer plus equals time dot delta time to add the time it took to get from the last frame to the current frame onto our timer value. And then we want to check if our timer is greater than or equal to the idle time for our current point. So we'll say points, current point index, dot idle time. Okay, so if this if statement executes, it means our timer has expired. So first thing, we'll set our timer off by saying timer is equal to -1. Then we will increase our current point index by 1. Now we need to keep in mind that we don't have an infinite amount of points. We need to check if we are beyond the end point, if our index is beyond the end point, and if it is, we need to reset it back to the start of the array. So underneath where we increment our current point, we'll say if current point index is greater than or equal to points.length. Then we're just going to set current point index equal to 0. So back to the start, the very first index of our array. Okay, and that's actually the update method. So the next thing we need to define is our trigger functionality. So I'm going to inherit the onTriggerEnter method as well as the onTriggerExit method. I'm also going to change these so that they have a protection level and that they are virtual. But we'll start with onTriggerEnter. Now, the reason we need to actually use trigger functionality to achieve this moving platform is if the player is on top of the moving platform, their position and how they calculate their movement needs to be based on the local coordinates of that platform. So we can make sure this happens by when the player lands on the platform, just parenting the player to the platform itself, and then when they leave the trigger, unparenting the player from the platform. So we'll open an if statement inside onTriggerEnter, and we'll say if other.compare tag is equal to true, and the tag we're checking for here will be player with a capital P. And if that's the case, we're just going to simply say other.transform to get access to the player's transform. Then we'll say .setParent, and we'll pass it our own transform to set the player as a child of this moving platform. Then for onTriggerExit, we're going to do a similar thing. So we'll say if other.compare tag equal to true, player, except we are going to say other.transform.setParent and then pass it null to make sure that the player no longer has a parent. Now I might quickly just write a couple of method summaries for these. Okay, so last of all, we need to define our reset platform method. And what this is going to do is it's not only going to be used at the start of the game, it's also going to be used whenever the player has a life subtracted and they're teleported back to a position. Because we want to reset each platform to their previous point whenever that happens. So it kind of feels like the platforms start where they should when the player dies. So this is going to be a public method, and we're going to make it virtual. This needs to be public because other scripts will need access to this, and virtual because this method will need to work differently for our DeathWall platform that we make after the moving platform. It's going to have a void return type, and we'll call it reset platform. So here we're just going to open an if statement, and we're going to check to see if our current point index is greater than 0. If it's greater than 0, we are able to subtract 1 from our current point index to just go to the previous point. If it is not greater than 0, then we need to go to the last index. So we'll say current point index is equal to points.length. But then remember that indexes are always 1 less, than the total length. So we'll say length minus 1. Then after that, underneath the else statement, we'll reset the position of the platform. So we'll say transform.position is equal to points. And then inside some square brackets, pass it our current point index. Outside that, say .point.position. And after doing that, actually, we'll just quickly write a method summary for this. Keep it consistent. Resets the platform position to the previous point. Just like that. And after we do that, we can come back up to the start method and replace our comment with a call to reset platform. Okay, so let's save that script. But before we go into Unity, let's just open our GameManager script. So I'm going to open the Solution Explorer and open GameManager. Now, what we need to change about our GameManager is we need to keep track of all the moving platforms in the scene and then just call their reset methods whenever the player has a life subtracted. So where our reference type variables are, we're going to have a private variable of the type moving platform, but it's going to be an array. So we'll follow that with a set of squared brackets. And we'll call this moving platforms. Then in the awake method, we need to actually set our moving platforms variable to a reference to, a bunch of moving platforms. So we can easily find all of the moving platforms in the scene by saying moving platforms is equal to find objects, note objects, so plural, objects of type, and we're looking for moving platform. Next, let's just scroll down to our private methods here. And I'm going to create a new private method, which will be void of a return type. And we'll just call it ResetLevel. And you could add, extra code if you wanted other stuff to happen whenever your level resets here. But what we want to do here is loop through every platform in our moving platforms variable and call that ResetPlatform method on each one. So we can use a for each loop here. So we're going to say for each, we're expecting the type moving platform. And we'll refer to each individual platform in the list as platform as we're iterating. So we're looking for each moving platform, which referred to as platform, in our moving platforms variable. And here, we'll just say for every platform that you loop through, call the ResetPlatform method. Then let's scroll down to our subtract life method. And if lives is greater than 0, so if we still have lives left and we're having a life subtracted, this is where we'll call ResetLevel. So if the game's over, we won't bother because it's going to reload the scene. But if we're just having a life subtracted, this is where we're going to call our ResetLevel method. So then we can save the script with Control S, and let's head back into Unity. Okay, so I'm now back in Unity. Let's select our moving platform. And on our moving platform component, you can see we now have a speed variable, which we can toggle. And we also have this points array. So I am going to have, let's say, 3 points. Okay, so we can see there are now 3 elements in our points array, and let's open each one. And each one we can see has 2 values associated with it. It has a point, which we actually need to drop in there from our scene when we create them. And then we have idle times. So let's go ahead and create some points. I'm just going to use empty objects. So right click in the hierarchy and create a new empty. We'll call this moving platform point and 1 in brackets. That way I can easily duplicate them and keep track of the number of points there are. And then we will reset the transform and move it so we can see it. And just like we did for our spawn point empty object over here, we need to give it a little gizmo. So with the object selected in the hierarchy, in the inspector, I'm going to click on this little cube here above the transform component, and our spawn point was a red circle. So let's make this a pink diamond. There we go. So I need 2 more because I need 3 points in total. So I'm just going to duplicate this twice. And let's spread them out. So let's select them all actually and just move them over here. And let's just, set them up in kind of like, the shape we want our platform to move in. So I'll leave the first point there, move the second point there, and let's just put the middle point there, okay? So we'll have it move in a triangle like this. So I've created those points. Let's just select our moving platform again and drop each point in the order that we want them to be moved between. Okay, cool. So let's hit play and test it out. Okay, so the game started. You can see that our platform snapped, to the last point when the game started, and that's because we called the reset method on it. You can see it's moving between the points. Let's actually go and jump on it with our player. All right, and you can see our player. It's hard to see in the game view, but you can see that our player. Let's reset in the scene view here. Can actually, is moving with the platform. It's parented, and if we jump off, we can see, that we stop moving with the platform, we run off and we go back to normal movement. One thing, let's just quickly demonstrate. Okay, so let's say we want to wait for 1 second at the first point and then half a second at the second point. If I hit resume now, you should see that gets to that last point, waits for half a second, goes to the first point, waits for a full second, 0 at the second one, and just repeats that endlessly. Cool. So we've created, a very simple moving platform here. But how do we actually turn this into something that will cause the player to lose the game when they make contact with it? Okay, so let's make our death wall and find out how we can do that. So first we'll set it up in our scene. So I'm going to right click in the hierarchy again, go to 3D object and create a new cube. And we'll rename this as death wall. Let's reset the transform component and just move it somewhere away from the player for now. And I'm actually going to make sure that I am in local view here, because it's actually pretty important. And we'll know that if we rotate the object in a direction, the gizmo and the blue arrow will rotate with the object. Now the reason that's important is because the death wall platform that we're going to be creating here uses the forward position to determine which way it should be facing as it's moving. What that means is that the direction this blue arrow faces is going to be the front of our platform. So we need to take that into account as we rescale this object as well. So let's change it on the X to 5. So it's going to be 5 units long, and I want it to be not as high as it is wide. So we'll say 3 units on the Y. So now we have this kind of platform. Now 1 unit is a bit thick, so I'm just going to half that to 0.5 on the Z. And now if we want to rescale this, basically we wouldn't touch the Z. Now the next thing we need to do is add a box collider, just like with our moving platform, except this box collider is going to be used to determine when we've hit the player. So for our first box collider here, we'll set his trigger to true. And then I'm just going to set the center for the Z axis to a value of 1, so that our trigger sits in front of our moving platform here. Now we do actually need to add a rigid body component to this object as well, if we want it to detect collisions with objects that don't have a character controller component on them. But I'll do that later and actually demonstrate that in action. Okay, so the next thing we need to do is create a new script. So I'm going to select add component, and we'll type in death wall and select new script. So that's death wall with capital D and capital W, no spaces for the name of the script, and then select create and add. And then we'll open the script from the project window. Okay, so here is our death wall script. Now the first thing that we need to do is change our inheritance from mono behavior to moving platform. And you can see as soon as we do that, we get these green warning lines underneath our start and update methods. And if we hover over them, they're basically telling us that this start method inside the death wall class hides the start method in the moving platform class, and the same for the update method, as we can see. And like I said, what we actually want to do is we want to override those things so that we can execute different functionality in either of these methods. So in our start method definition, we'll say protected, because that's the same protection level as the start method in our moving platform class. And then instead of virtual, we'll say override, which means that we are going to override the start method in the moving platform script. Now in this case, I don't actually want to completely override the start method. I just want to extend it. I still want it to execute the functionality defined in the start method for the moving platform class. So to execute that, we say base, and then we can call the original version of the start method from the base. Okay, so underneath that, the extra thing that we want only our death wall to do when the start method is executed is to face the direction of, or to face its current point. So we're going to say transform.forward to set which direction the forward facing direction of the object is going to face. And here we want it to face the direction of the current point. So we need to get the direction from this object to the current point. So we're going to say transform.forward is equal to, and we can access our points variable here, even though that's defined within MovingPlatform, because we inherit from MovingPlatform, and points was a protected variable. So the same thing goes for our current point index variable. We can also access that. So we'll say points, then open some squared brackets and pass it the current point index, after which we'll say dot point and then access the position of that point. And from that, we'll subtract transform.position, which is the position of the DeathWall object. And that's going to force the DeathWall to face its current point at the start of the game. Now, before I go further, I'm just going to quickly turn these comments into summaries as per usual. And we will get to the update method in a second. But first, let's define the data we will need for our DeathWall. So the only other variable that our DeathWall will need will be a private variable of the type GameManager, and we'll just call it manager. But we are actually going to need to create one other form of information within our DeathWall class. So we know that a class is a container for all kinds of information, basically variables, methods, and the methods that are defined within a class will usually have the functionality that's executed defined within those methods as well. So an interface is a container for methods as well. However, it doesn't define the functionality for the methods. It's a container that classes can inherit from that forces them to implement a certain method, but doesn't tell them exactly what that method is supposed to do. So we're going to make this a public interface. So we'll say public and then follow that with the interface keyword. Then we need to give the interface a name. Now, when we are naming interfaces, you'll usually start with a capital I to indicate that it's an interface type. And we'll call this DeathWall Destructible. So this interface is going to just contain one very simple method, which will have a void return type, and we'll call it on DeathWall collision, and it's not going to take any parameters. Now, because this is in an interface, it doesn't define what the method actually does when it executes, so we just end the definition there. So let's chuck in some summaries here. First, we'll do the method, and we'll say use this method to define how an object is destroyed by the DeathWall, or by a DeathWall. All right, and then we'll also do one for this interface here, and we'll say inherit this interface to mark an object as destructible by DeathWalls. Okay, so if we want to make an object destructible by a DeathWall, we just need to make sure it inherits from this interface. Okay, so that's our interface definition completed. The next thing I want to do is just inherit the awake function. And here we're going to say manager is equal to find object of type GameManager, just to make sure that our manager variable has a reference before we start using it later on in the script. Okay, so now let's go down to our update method and fix this. So just as in the MovingPlatform class, this is a protected method, and we are looking to override it here. Now, we are not looking to call the base version of the update method because we don't want to extend it. We want to completely override the original definition of the update method. So although DeathWall extends the base definition of the start method because it's still calling the base definition, the update method here is going to completely override it. So DeathWall will have a completely different update method to the MovingPlatform class. It will be similar though. So it is going to work in the same two blocks. So we'll say if timer is greater than or equal to 0, else if vector3 distance is less than 0.1f, and the distance we are looking for here is between transform.position and points, current point index dot point dot position. So, and this is going to, again, this will do the same in this section here. So we'll say if timer is less than 0, we'll turn our timer to 0. And again, this first statement will also be very similar. So we'll first increment our timer by saying time plus equals time dot delta time. And underneath that, we'll open an if statement and check to see if our timer is greater than points, current point index dot idle time. And if it is, we'll set our timer off, set it to -1, and we'll increment our current point index. And here is where things slightly deviate from the base definition. So we're going to check if current point index is greater than or equal to points.length. So if we have reached the end of our list of points, we're actually just going to say GameObject.setActive and pass it false, which will turn the death wall off. So once the death wall has reached the end of its path, instead of going back to the beginning, it's just going to turn off. But if it hasn't reached the end of its path, it will execute this else statement here. And here, we're just going to set transform.forward equal to points, current point index dot point dot position, subtract transform.position, which will of course make the death wall face its new target point. Okay, so that's the update method done. Now we need to override our trigger functionality. So we can quickly inherit methods that we can override. So I'm just going to start with the protection level and then say override. And you can see IntelliSense suggests the on-trigger enter and on-trigger exit methods because they're the only methods that are marked as virtual. So we'll inherit both of them. And we will actually not call the base functionality for either method. Now, actually, we don't want the on-trigger exit method to do anything. So we're just going to leave this completely blank. And actually, let's just add a quick method summary. Okay, so again, we don't want anything to happen in on-trigger exit, but we are going to do some stuff in on-trigger enter. So first of all, we want to check to see if it's the player colliding with the trigger of the death wall. So we'll say if other.compareTag is equal to true, and we're looking for player here. So here what we want to do is we actually want to call game over from the GameManager, but that's currently a private method. So let's go over to our GameManager script really quickly and scroll down to our game over method. And I'm just going to change the protection level here from private to public, and then hit Control-S to save the script. And once I do that, if we go back to our DeathWall script, and write over this comment, we'll say manager.gameover. So that's going to cause the player to stop being able to move and reset the level when they press a button. But to make sure the wall stops moving, we'll say enabled is equal to false. Now this is not affecting the whole object. This is just disabling the component. So in this case, DeathWall, because that's the component this is written within. So we're turning the DeathWall script off, which means that the update method will no longer be executed. What if the object colliding with this trigger is not tagged as the player, but inherits from our DeathWall destructible? If that's the case, we want to call the DeathWall collision method defined within that interface. So we'll say else if other.tryGetComponent is equal to true. Okay, so we're trying to get a component here from the object stored in other, which is the object colliding with the trigger. So inside tryGetComponent, we first need to say out because we're trying to push the component out into a variable reference. and we'll define this variable reference as of the type DeathWall destructible. So it's going to store a reference to a script that can be read as that interface. And let's just call it destructible. So this is our local variable that references the DeathWall destructible attached to the other game object. So if it is actually able to successfully find that interface on the object, we want to call a method from it. So we'll say destructible dot, and here we can call our onDeathWall collision, which is the only method that exists within the interface. And that's all the functionality that we need to define for our onTriggerEnter and onTriggerExit methods. The last method that we need to override is our ResetPlatform method. When we reset the DeathWall, we just want to check to see if it's going towards a point beyond the first point. And if it is, we'll subtract the current point index by 1 to set it to the previous point. So this method was public, and we'll say override. And we can see there it is right there because it was marked as virtual. So let's inherit it. And we don't want to call the base version of the method, so let's remove that. Here we just want to check if current point index is greater than 0. So if we're moving to a point that is beyond the first one, then we'll subtract current point index by 1 by saying current point index minus minus. And then underneath that if statement, we'll say transform.position is equal to points. I'm going to open a set of square brackets, current point index inside the square brackets, then dot point, dot position. And we'll write a very quick summary. And we'll just say, resets the position of the DeathWall to the previous point. Now, one thing to note about this method is it only does that if the current point index is not the first point. If it is the first point, it's actually going to set its position directly to that point because it's not subtracting 1 from the index, and it's just moving straight to that. So we need to keep that in mind as we're setting up the points for our DeathWall, just remembering that it's always going to snap to that very first point at the start of the game. Okay, so let's save the script with Control S. Now, we're nearly done. The last thing we need to do is make a very quick modification to our MineAgent script. So I'm going to open my MineAgent script with the Solution Explorer. Now, what I'm going to do here is just set the MineAgent to be an object that can be destroyed by the DeathWall. So this class already inherits from another class. Now in C#, a class can only inherit from one other class. And we want this to inherit from MonoBehavior. But what we actually want to inherit from here is an interface. And in C#, a class can inherit from as many interfaces as you need. So after MonoBehavior here, we're going to write a comma. And after the comma, we can define the interface that we want to inherit from. Now we defined our DeathWall destructible interface within the DeathWall class. What that means is to access that DeathWall destructible interface, we need to first access the DeathWall type. So we'll say DeathWall followed by a dot, and then underneath that we can see two things. We can see platform target point because that class was defined within the moving platform, and then we can see the DeathWall destructible. So let's inherit from that. And when we do that, you'll see initially we get an error. If we mouse over it, it says MineAgent does not implement interface member on DeathWall collision. And what that means is we need to override the on DeathWall collision and actually give it some functionality. So what we actually need to do is at the bottom of our script here, we'll create a new public method with a void return type, and we'll call it on DeathWall collision, and it will have no parameters. And just to demonstrate, as soon as we do that, you can see that the error at the top of the class disappears. So next, let's define some functionality for this method. And in this case, all I want the MineAgent to do when the DeathWall collides with it is I want it to call its detonate method. So here, I'm just going to say detonate which already causes the mine agent to explode. Then I'm going to save the script. In fact, I might just come up to the top here at Visual Studio and hit Save All to make sure all my scripts are saved. And now we can go back into Unity and test everything out. Okay, so I'm back in Unity. Let's select the DeathWall. And we can see that on our DeathWall component here on the object, we actually have a speed variable and a points variable, just like we did for our moving platform. So let's open this up. I'm going to give it 3 points. And now we actually need to create another set of points for this platform. And we could use the same set of points, I guess, but let's keep it fresh. So I'm going to duplicate one of my moving platform points. I might just change it to the name to DeathWall point to keep my naming in the hierarchy clear. And let's duplicate it a couple more times. I'm going to just move them over, say here, remembering that the DeathWall will snap to our first point. So I'll set my first point there. I'll set my second point here. Yeah. And then I'll set my third point like over here somewhere. Just so we can test to make sure that it faces the right point. So then I'll select my DeathWall again, drag each point into the point slot of each point. And at this stage, we're pretty much ready to go. So let's hit play and see what happens. Okay, so I'm in play. We can see the DeathWall moves and it gets to its next point and changes, but it hit that mine agent there. It just missed that other one, but it hit that first mine agent and we can still see it walking around. It obviously didn't detonate. Let's just test to see if it works with the player. So I'm going to reset the scene. Okay, so with my player, I'm just going to walk in front of the DeathWall. And when it collides with me, it should stop. Good. And we can see in the console, it says game over. So if I click any button, it reloads my scene. Now, the reason this works with the player, but not the mine objects, is because our player capsule here uses a character controller. And character controller collisions work, they function correctly with trigger colliders. However, any other object that just uses a collider and does not use a character controller component will not inherently collide with trigger colliders. If you want objects that don't use a character controller to collide with trigger colliders, one of the two colliding objects need to have a rigid body. So we could go and add a rigid body to each of our mine agents, but in this case, I think it's probably just an easier idea to add a rigid body to our DeathWall. So with our DeathWall selected in the inspector, I'm going to click on Add Component, and I'm going to look up rigid body. And make sure you add a rigid body and not a rigid body 2D. So let's select rigid body. And I might just move this up in the inspector sort of hierarchy there. And here's our rigid body component. We can use this to apply Unity's built-in gravity to any object. In this case, we don't actually want to use gravity. So I'm going to turn use gravity off and is kinematic on. The other thing I'm going to turn on here is all of the constraints, because I don't want the rigid body to have an impact on the position or the rotation of this object. So we'll just select all of the constraints for the rigid body. Now, if I just reposition my camera more appropriately and hit play, you should be able to see that when the object, when it collides with our mine agents, they now detonate as soon as they hit the DeathWall's trigger collider. So that's it for this tutorial. I hope you found it useful. If you did or you enjoyed the video, please leave a like. And if you'd like to see more game development content and tutorials like this, you can hit the subscribe button. Thanks for watching. I hope you enjoy yourself.